in your notes. Why isn't this thing on? Hello?
Hi.
Check. 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 All right, in your notes, on page 4, terminology for redox reactions. We're going to do this old school since I don't have a projector today.
I see one.
Bulb's burnt. It's not working. Okay. Terminology for redox reactions. Oxidation.
What page is it, sir?
For oxidation to occur, something has to lose electrons. Oxidation, lose electrons. Why are you talking? Okay, we're on page 4, Leslie. Upper right hand slide. Reduction. For a reduction to occur, for a substance to be reduced, it must gain electrons. Okay? If you look down below, oxidizing agent. The oxidizing agent is the species that causes the other substance to be oxidized. So the oxidizing agent is reduced. The oxidizing agent is reduced. If one thing loses electrons, something else must gain electrons. They're not destroyed in the redox reaction. They are matter. If something loses electrons, something else has to gain them. They have to go somewhere. So you can't have two species in a reaction get oxidized and nothing get reduced. Okay? You can't have one without the other. So the oxidizing agent causes the other substance or other species to be oxidized. It is reduced. The reducing agent gets oxidized. Okay? The reducing agent gets oxidized. It's like if you have a travel agent. Who goes on vacation? You or the agent? You. You do. The travel agent doesn't go on vacation. The travel agent doesn't travel. You do. The reducing agent isn't reduced. It's oxidized. It causes the other thing to be reduced. Are we clear about that? Okay? The way I was taught to remember this is Leo the lion goes Gerd. You know Leo's the lion, right? Leo the lion. Where'd you guys go to school? I'm gonna shut the door. Leo the lion. Leo. Can't write today. L-E-O. Leo. Lose electrons, oxidized. Leo. Lose electrons, oxidized. Leo the lion goes Grr. Gain electrons, reduced.
Leo Grr.
Leo the lion goes Grr. Leo the lion goes Grr. That was a Grr.
That was a.
That's not even a
That's not a
word.
girl, that's a.
Leo the lion goes Grr. Want to hear it again? Trying to drive the point home?
Yeah.
One more time.
You understand now?
I
One more
don't know.
time.
No, mister. Play it one more time and then I'll get it.
Yeah.
Can you say what they mean again?
Seriously?
It's on paper.
It's on your paper.
Oh.
Oh! That's why he picks these out for lose electrons oxidized.
How many times Mexican?
That's Leo. Gur is what he says. Does that sound like a lion? Gur. Gain electrons reduced. That's the way I learned it when I was in high school, about your age. And then I came to Texas and I also discovered that there's another way. Oil rig. Oil. Oxidation is lose. Rig. Reduction is gain.
Leave the line sister.
Yeah, I like that one too. Okay. All right, we're in the notes. We're gonna skip ahead. Stay with me. Skip ahead to page. We're gonna come back to some of this, but I want you to skip ahead to page 6. Also, the upper right-hand corner. We're gonna go over Hello? Oxidation numbers. Okay, and for those of you who maybe had someone else as a pre-AP chemistry teacher, many teachers use oxidation number synonymously with charge, like say the charge on an ion. I kind of avoid that, and now you'll see why I avoid it. Oxidation number isn't necessarily the charge on an ion. It can be, but it isn't always. They're not synonymous. So when we were talking last year about, say we have a magnesium ion, I always told you that was magnesium 2+. If I asked you a question, I would say, what's the charge on a magnesium ion? Some people will say, what's the oxidation number of the magnesium ion? And for this, in this instance, they are the same thing, but charge is not always oxidation number. Okay? Oxidation number is basically something we use for bookkeeping for electrons. And before the end of the class, you'll see what I mean by that, but they are not synonymous. So I try to avoid saying oxidation number when what I really mean is charge on a monatomic ion. There are some rules for determining oxidation number. Rule number 1, free elements in uncombined states have an oxidation number of 0. So if I have elemental magnesium metal, that would be an oxidation number of 0. Sodium metal, oxidation number of 0. H2, hydrogen. This is an element in its most stable form. Its oxidation number would be 0. Okay? Any questions? Okay, then number 2. Please no coughing when I'm trying to teach. Number 2, in monatomic ions, what's a monatomic ion? Mono means 1, so 1 atom, monatomic ion. So that would be like potassium or sodium ion. For monatomic ions, the oxidation number is equal to the charge on the ion. Why are you disrupting the class? Okay, so far so good? The first 2 are pretty easy. Jess? All right, number 3. The oxidation number for oxygen is usually 2-. Say, for example, we have the oxygen in water. The oxidation number of this oxygen in this compound is -2, or 2-. Okay? The exception for when oxygen is in a compound is hydrogen peroxide, H2O2. In hydrogen peroxide, the oxidation number of oxygen is -1. Okay? So oxygen can be -2. Most of the time when it's in a compound, it can be -1 if it happens to be in peroxide, and this is an exception that they like to use on AP exams. You'll see hydrogen peroxide a lot. And you'll be expected to know that in this case, oxygen is 1 minus. And we can also have oxygen just as an element in its most stable form. What would the oxidation state of O2 be? 0. Okay?
What would be oxidation number?
Here?
Yeah.
Because it is.
There's not-
Huh?
There's not really explanation for it.
Well, it's bonded with, we have 2 oxygens bonded with 2 hydrogens, and it has to come out neutral. The only way it can do that is for each of these to be 1 minus, because the hydrogen, which we'll get to in a minute, all questions will be answered if we can get through it. The hydrogen here is 1 plus. Does that make sense? Okay. Where are we? Rule number 4. Hydrogen. Glad you asked. Hydrogen is usually 1 plus. So why did I erase that? The hydrogen in the water is 1 plus. Hydrogen and hydrogen chloride, hydrochloric acid, would be 1 plus. If we have a metal anhydride, sometimes hydrogen can bond with metals. It has 1 electron. It can gain 1, it can lose 1. If we have a metal hydride, what do you suppose the hydrogen is here? 1 minus. Yep. Here it's 1 minus. Or we can have H2, hydrogen alone as an element in a molecule, its most stable form. What is the oxidation number of this group? 0. Good. 0. Next rule. Group 1A metals are 1 plus, 2A metals are 2 plus, and fluorine is always 1 minus. We've always gone by group 1 and 2, groups 1 through 18. 1A is group 1, alkali metals. So sodium, potassium, lithium, those guys. They will always be 1 plus, no exceptions. Group 2, 2 plus. Fluorine will always be 1 minus. Okay? Or 0 if it's F2. If it's this, F2, that would be 0. But if it's in a compound, hydrofluoric acid, it would be 1 minus, always. Leslie, you have a question? Next rule. The sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge on the molecule or ion. Bet that makes no sense, does it? Okay, we need an example. The reason we need an example is if you look at the very next slide, there's kind of a periodic table. I wish I could project it for you so you could see it better. If you have your magnifying glass, go ahead and get it out. Okay, mister. Yeah, I'll get that right out. If you look at most of those elements, you don't have to be able to read it, but if you look at chlorine, there must be 6 or 7 different. If you look at chlorine, there must be 6 or 7 different possible oxidation states. It's hard to count them. Each of those is a different number. Right under fluorine, it's only have 1. Okay, all those other elements that we don't have a rule for can have multiple oxidation numbers. Okay, you don't have to know this, you don't have to memorize it. This is just to show you all the possibilities, all the possible oxidation numbers for all the other elements that don't fit into those first 5 rules. Okay? Now 6, the sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge on a molecule or ion. Our example in our notes is HCO3. Is there a charge on this ion? 1 minus. So the sum of the oxidation numbers of all the elements in this compound will equal -1.